So for the previous video, we have discussed what an array is and what the purpose of an array is. So um, as with other declarations or what with other variable declarations, array also needs to be declared. Okay, so and in an array in a variable declaration, what we need is the array's data type. So in other words, we have to specify whether the array is contains integer values or it contains double or floating type na values or characters, let's say. Okay, so and then we also have to specify the name of the variable array, and then um, we have to end the declaration with a semicolon, right? So in addition, an array declaration has also a length, which is enclosed in square brackets. So the length is refers to the number of elements, that uh, in the array, right? So here's the formal syntax of array declaration. So first, you have to specify the type and then the name of the array, and then followed by the length, which is enclosed by the square bracket. So just a few things to remember. The length should be an integer that is greater than 0, and the type can be any valid C na data type. Right. So going back to our earlier example, we want to declare an array of grades with 5 elements. So these 5 elements refer to the grades of the 5 students that we want to store, or let's say compute. Okay, so uh, we can declare this in C by this statement. So first, you have to specify the type. So since a grade could be a decimal, like 94.55 or 84.5, right? So we can declare it as a float. And then we specify the name of the array as grades, and followed by the length, or the number of the members of the array. So in this case, we have 5 na grades. So we only want to input um, grades for 5 na students. So what this does is it reserves a memory for 5 na contiguous floats. Right. So since array lengths need to be adjusted when the program is changed later, so for instance, we want to adjust the number of student grades that will compute. So we can define we can use a macro to define the length of an array, right? So example, we use a macro define, and then we set the length of the array and as 5, right? So and later on in when we declare our array, so we just instead of using a magic na value, so if you remember what a magic value is, we will be using the variable n with a constant length of 5, right? So other examples. So let's say we want to declare an array variable coordinate with a three with three members, right? And then we declare it's a double. And so what it means is each element is declared as a double, and it reserves space for 3 na elements. And let's say another example, we declare an array frequency with a type integer, and that has 26 na elements. So what it does is it reserves space for 26 na elements. So now, how do we access the elements of an array? So let's say we have this array na grades, and we only want to compute for the average of the grades of this 3 students only, right? So we have the 85, the 97, and 16. So how can we access these three na grades for these 3 students? Okay, So to access a particular na element of an array, so we write the array na name. So in this case, our array is grades followed by the integer value in square brackets. So this is what we refer to as subscripting or indexing. So suppose we have this uh, member, uh, we have these elements of the array grades that are conceptually arranged one after the other. So this first element is the we and if you remember before, and then in order for us to access the element of an array, we need to specify its position in the array. So in this case, 57 is the first on our array. So and then we index it as 0. All right. So we access 57 by with this. So grades of 0. So its position in the array is 0, is first. So we don't start with 1 but with 0. All right. So and then for the second element, we access it by grades of 1. Right. So 0, 1, and then and so on. So the other elements just follows. Okay. So elements of an array of length n are indexed from 0 to n minus 1. So, for example, if grades in an array with 5 values, they're designated with grades of 0, grades of 1, and up to grades of 4, as the figure shows. So, again, as mentioned, the first element, it starts with 0, and then the last element is n minus 1. So, the n refers to the length of the array. So, if we have 5 elements, so the last na element will be accessed with n minus 1 or 4, all right? Okay, so the grades 0, grades of 1 until grades of 4 are L values. So meaning we can assign values to them and they can be used the same way as ordinary na variables. So looking back to our previous na example, right? So imagine there are only 5 students in a class, and then again we have this scores. And what we can do is um, treat this each na member of the array as an ordinary na variable, right? So first, we declare our array floats. We declare the array grades with data type na float with 5 na elements. So as we have mentioned, each of the member of the array acts like an L value or like an ordinary variable where each of these L values can be assigned values to them. So we can assign the grades of 0 or the first element in the array as 57, right? So and then we also assign 85 to the second na second um, student, and then 97 to the third, 16 to the fourth, and 82 to the last na student. So again, array elements work like typical na variables. So it means that we can perform operations with them. Okay, so for example, we want to update the grade of the first student. So let's say nagkaroon ng bonus points. So we want to add a 2 to the grade of student. So since the variable, so since this behaves like a variable, we can access each element and perform operations with them.